Let's now look at some of the main ideas in Chapter 6. Starting on page 373, again up here at the top center of the screen, you should be able to keep up with what page number I'm on in the e-text. You'll see that there is a quick video introduction to section 6A, and as always, I highly encourage you to watch that video. What we're going to find in this first section is that to describe distributions, we can use center, shape, and spread. So there's a little bit more to say about center of distributions or measures of center here on page 375. These are three common measures of center: mean, median, and mode. And notice there is a little bit of a formula here. There's as well some examples below that tell you how to calculate these values. And there's a side note about outliers on the next page and how outliers can affect the mean, but not as much the median. So if we know we have outliers in our data, it may be better to use the median as a measure of center. And then up after that, we have on page 378, what does it mean to have a certain shape of a distribution? So there's lots of examples here of shapes of distributions. And you can see in these graphs, some of them have one peak or two peaks, things like that. And that tells us things about the mode. We have, I believe it's on the next page here, some ideas about symmetry versus skewedness. Again, lots of visual explanations about what's going on there as well. And then last but not least, to describe a distribution, we can use the spread. Now, our text calls it the variation, but variation is a measure of spread. It tells us how spread out the data is from the center. So you can see this one's not very spread out, so that's low variation, versus this last data distribution here is really spread out. It's as if somebody had took both ends, like this right end and this left end, and spread it apart to make high variation or high spread. Moving on to the next section on page 386, what we find is an introduction video here to more information about measures of variation or measures of spread. And what we're looking for here in this particular section is more about quantifying variation. And there's lots of ways we can do that. There's some formulas provided in this section, examples as well. There's even ways that we can visualize spread by drawing a box plot. You may have seen a graph like this, maybe even have called it a box and whiskers plot in the past. But here are the steps to doing a box plot as well as examples below. One more thing I want to point out in this section is a technology tip about how to use Excel to find the standard deviation. That's one of a few different ways we quantify variation in our distributions. After that, the next section we have starts on page 397. And this one's about a very particular distribution called the normal distribution. It's a very standard distribution that's seen very often in lots of different data. It's also called a bell-shaped curve. And there are conditions that are required here on page 398 for a normal distribution. So read through that list to make sure that it meets these conditions so that we know that we have a nearly normal distribution. On page 399, the nice thing about having a normal distribution is we can then apply this statistical rule called the 68, 95, 99.7 rule. And what that means is within one standard deviation of the center, I have 68% of the data. That's all the stuff I see here in the dark green region. But if I go 2 standard deviations out from the center, I now contain 95% of the data within those 2 standard deviations. So that's the light green and the dark green together. And then if we go 3 standard deviations out, that looks like the lightest green to the darkest and back, That's 99.7% of the data. Almost all of the data would fall within 3 standard deviations of the mean in a normal distribution. So that's a really cool rule that we can apply. You'll see some examples of that in the text as well, along with videos, if you need to see the video to help walk through those examples. On page 402, there's a formula here for z-scores or standard scores. Sometimes we use these whenever we want to standardize our data. And then on page 405, there is also a piece here about using Excel to find standard scores and percentiles in Excel. The last section in this chapter starts on page 408, and it's about statistical inference. And I would say there's a lot more that we could do here with statistical inference than what's just in this section. But it's a really neat topic because it allows us to infer something about a population just based on a sample. Okay, so again, watch the video here for a brief overview. And the things that we'll focus on in this section, just to kind of keep it a little bit simpler than, say, a true statistics class, is we're going to focus on statistical significance, margin of error, and hypothesis testing. And for some of you, this may be the first time you've used any of those terms. So again, take your time looking through the vocabulary and really reading with the vocabulary here. On page 410, we see here a way to quantify statistical significance. And here's some good examples of that in the purple rectangle as well as on the next page. On page 413, this is a neat image I wanted to include here of a confidence interval. And what we find is that all these different samples, there's only one sample that doesn't include the true population parameter. So that's only one of 20 samples. So in other words, 5% of samples will have a confidence interval that does not contain the true population parameter. So that illustrates an idea that on average we would find 95% of samples, of any set of samples, will have a 95% confidence interval. In other words, it contains that true population parameter. I thought that particular graph was very interesting. I've seen that in other areas, even outside of mathematics courses. Okay, and then after that, on page 415, we start learning here about hypothesis testing. And for hypothesis testing, really we're trying just to test the validity of something that's being claimed to be true. All right, so we have to have a null and an alternative hypothesis, and you can read more about that here. On the next page, we'll see how we can state the outcomes of a hypothesis test. Either we reject the null hypothesis or we do not reject the null hypothesis. So you'll see here that the wording is very particular for a reason. And as you continue your studies in statistics, maybe in other courses, you'll continue to use this same wording. And then on the next page, we see how we make decisions with hypothesis tests. Okay, so this is the hypothesis test decisions. So again, there's some examples, videos to explain these examples as well. I understand that this last section in particular may be very new to most people, so take your time with that. Last but not least, on page 423 is an overview of the full chapter. We did all the sections in this chapter. So you can see, again, a lot of vocabulary and maybe very new vocabulary for most people, and as well new formulas perhaps, or at least a reminder of some formulas here. Again, don't forget to reach out and ask me questions with Ask My Instructor on specific problems that you may be having in My Math Lab, and I will reply with a videoed response.